Right, good afternoon, everybody. I hope you're having a wonderful summit. Thank you so much for coming. We are incredibly excited for our next talk. It's going to be the essential guide to operating Bitbucket server and data centers. We know a lot of you are running Bitbucket in your mission-critical environments, and we are excited for this next talk. So please welcome to the stage Rick Friend.
Hey, good morning, everybody. Can you all hear me okay? Okay, great. So, as you'll soon see, Bitbucket Server is fairly unique when it comes to managing a web application. And I really believe in order to effectively operate a Bitbucket Server or data center instance, you need to have a solid understanding of how Git works, what Git's resource consumption looks like, and how Bitbucket Server was designed around Git's unique characteristics. And that's what I aim to give you in this talk. So first of all, we'll talk a bit about Git. Then we'll move on to monitoring and maintenance. And finally, I'll tell you a little bit about how Atlassian Data Center can make your life as a system administrator a little bit easier. So what we see here are 3 resource utilization graphs for a Git clone, but which is which? When I first joined the Bitbucket server team about 3 years ago, I naively believed that Git would be primarily I/O constrained. After all, it's just serving up files to a client. Well, how wrong I was. As you can see, the primary resource consumers of Git are CPU and memory. And there's also a little bit of disk I/O, and even that disk I/O is a little bit specialized in that it makes use of lots of random reads and writes. In terms of memory, a full Git clone can consume up to 1.5 times the amount of memory as the repository size is on disk, and it can peg a CPU core for the entirety of a clone. So Git is really, really hungry for CPU and memory. Now, as I mentioned before, Bitbucket is fairly unique as a web app. Not only do you have all the usual concerns of a web app, security, SSL certificates, backups, so on and so forth, you also need to worry about these things called hosting operations, which are essentially the operations that Git performs when you do a clone or a push or any operation over Git. Not only that, you need to worry about hosting operations over HTTP and SSH. And for example, in your traditional web app, you're primarily concerned about latency, i.e., how quickly can you get a web page in front of your user? And while this is also very important in Bitbucket Server, you're also worried about throughput, i.e., how many bytes of Git data can you push out to your clients every second? The other thing to think about is that UI operations can and do invoke Git. For example, when you're creating a pull request, merging a pull request, viewing a diff, all those operations actually fork off a Git process. There's also some trade-offs to think about when you compare Git operations over HTTP or SSH. Over HTTP, normally the encryption is handled before it gets to your Bitbucket server instance, but all your authentication and authorization takes a much more complicated code path through the system, talking directly to your directory service and whatnot. Over SSH, encryption is handled in-app, but the authentication and authorization path is a lot more simple because we make use of SSH keys. On top of all of that, there's a REST API and webhooks that you need to think about. So, anybody who has administered a Bitbucket server instance for any length of time will have heard about hosting tickets. But what are they? Hosting tickets are a mechanism that we use to allow for graceful degradation of services. Like I mentioned earlier, Git is really, really hungry for CPU and memory. And if we just allowed any hosting operation through at any time, it would be pretty easy to crash your system in a pretty ungraceful way. How does that work? When your system starts up, it's given a certain number of available hosting tickets. Every time a hosting operation comes in, it acquires one of those tickets, and if there are no tickets available, that operation will go in a queue, and if that operation spends a certain amount of time on the queue, it will eventually time out. Prior to Bitbucket 4.11, and let me just say, if you are running a Bitbucket version prior to 4.11, please upgrade now, because you're missing out on lots of really awesome features. Anyways, prior to Bitbucket 4.11, the number of hosting tickets available in your system was fixed at startup, and it was normally some multiplication of the number of CPU cores on your system. But there was a big problem with this. The problem is that if you're doing a small fetch for a tiny utility project, the resource consumption compared to a clone of a massive monorepo is order of magnitudes. And so we were finding that systems were actually underutilized. So what we did was we introduced this concept of adaptive throttling, where the system samples CPU every 5 seconds or so and applies some smoothing to that metric and tries to work out if you could handle more hosting operations or less, and will adjust the number of hosting tickets available to you dynamically. Okay. Build storms. On our internal production instance, we can see up to 800 concurrent clones at any one time. Not only that, those 800 concurrent clones are for the same repository, and it happens to be one of our biggest repositories. There are a number of reasons for this. There can be a cascading effect where a build kicks off another build, which so on and so forth. And we actually think this number is going to go up over time as paradigms and processes change. We've heard from some people who plan to build the entire tool chain every time a commit is pushed to a repository, which is a pretty interesting concept. So, given what I've told you about hosting tickets, its intense need for CPU and memory, how do we handle load like this? The SCM-CACHE. The SCM-CACHE caches two types of Git operation: ref advertisements that are lightweight but frequent, and clones that are a much heavier operation. Anytime a Git client or a build agent queries a Bitbucket server to find out if it needs any changes, that's a ref advertisement. Anytime you do a clone or a fetch, that's a ref advertisement. And basically what that is the Bitbucket server saying, hey, these are all my refs, e.g. branches, tags, etc., and this is what the tip of the branch or the tag points to. And so if you have thousands of repositories on your build infrastructure, and your build infrastructure is polling every 60 seconds, every repository, this can really, really add up. Now, we do provide better mechanisms for doing this. For example, we've introduced webhooks fairly recently, but we find a lot of our customers are still using polling to discover changes on a Bitbucket server instance. When you push changes when a client pushes changes up to a Bitbucket server instance, that cache is invalidated, and the next request for a ref advertisement generates a new cache file. The other thing we cache is clones, and we actually use the pack negotiation, which is the dance that a client and a server do to work out what the most efficient pack file or set of data sent to the client is to determine the cache key for these clones. And the other thing to bear in mind is, remember how I told you earlier that a hosting ticket is required for every hosting operation? That's not true for SCM-CACHE hits. But this is another way to visualize it. So you can see, without the SCM-CACHE, every clone that comes into the system will fork off a Git process. While with the SCM-CACHE, it's basically a race, and the first hosting operation to hit the system will fork a Git process, and every other operation will read from the output of that Git process. And this is another view of of that happening, just like the resource graph we saw earlier, but with the SCM-CACHE in place. Now, as you can see, there's a high amount of Java IO read, and that's the Bitbucket server instance reading the pack file from the disk. You can also see there's a little bit of CPU and memory used by Git, and that's because in this particular instance, we had ref advertisement disabled. With the SCM-CACHE, your concurrency is basically limited to the per connection overhead of your Git operations and the amount of heap you have in your system. So to summarize, Git is really, really hungry for CPU and memory. Hosting tickets help to keep your system stable, and SCM-CACHE is your friend. So I want to discuss a few high-level pitfalls and gotchas when it comes to monitoring that I hope you all find useful. I want to discuss monitoring versus alerting and sampling versus events. So what we can see here is a graph of hosting tickets, queues used and available. And unless you're like really, really eagle-eyed, you won't be able to spot there's a tiny bump in the queued hosting tickets at the bottom of this graph. That's because the number of available tickets is very high, and spotting a change of 1 or 2 in that bottom metric actually becomes quite difficult. But if we change this to a log axis, these small changes can become a lot more visible. If you've got a large range of values without more value, it allows you to basically see a large range of values without a small values being compressed to the bottom. So what I'd say to you is if you are using monitoring, experiment with different axes to work out what sort of axes really helps to highlight the information you're interested in. And I'd also just like to point out that some amount of ticket queuing isn't necessarily a bad thing. The other thing I want to talk about a little bit is sampling. Now, sampling can hide important events. As you can see here, this is a database connection pool. There's a certain number of active connections and a certain number of total connections within the system. And you can see that there's been a spike in the total number of connections a number of times without actually capturing the increase in active connections. So sometimes we see the side effects of a metric change rather than the root cause. The other thing to bear in mind is when you're using a monitoring tool that makes use of sampling, very often they perform some sort of aggregation that can be lossy. So even if you're viewing very, very fresh data, there are only so many data points that a tool can sort of display in a web browser. So very often, your tools will perform some sort of aggregation, whether that's averaging, minning, maxing, and that can also hide data. If you're going to choose a monitoring tool, try to choose a monitoring tool that sort of stores the full resolution of metrics for some period of time. They're all slightly different, but if you have a tool that sort of starts averaging and compressing your data straight away, it becomes quite difficult to go back and really work out what was happening in your system historically. The other thing I wanted to talk about in terms of, so as you can see, here we have a graph of used hosting tickets. Can you spot the problem? Well, it's actually quite difficult to see what's going on, that there is a problem here. But if we add a derived metric to it, it becomes quite obvious that we've actually got a ticket leak within our system. So this is a real-world example that we use on our production instance to make sure that we always release hosting tickets. And this has actually prevented us from shipping bugs to you, our customers, a couple of times when we've alerted on these sort of metrics. And in this particular instance, we're basically saying the minimum number of tickets over a 60-second period. Try to choose a monitoring tool that allows you to do this sort of thing. It's really, really good for pulling the signal out of the noise. And very often you'll find a derived value is a lot more useful for alerting, because it prevents false positives. So in terms of the metrics I think you should be monitoring, I think these are pretty important. The other thing I wanted to mention is generally metrics come in two different flavors. You have gauges, which is a value at a specific point in time, for example, CPU or memory, and you also have rates of change, for example, pulls or pushes per second. Just as a note of interest, the way most monitoring tools work when they calculate these rates of change is that you'll have a counter that you'll say increment every time you receive a pull or a push, and the tool will know that it's sampling every 10 seconds. So if it sees, for example, maybe an increase in 100 over 10 seconds, it will sort of average that out to 10 pushes per second, while a gauge will just sort of be an instantaneous value. So when you set up these metrics in the tool, make sure you choose the right type of metric, or you'll just see like really, really crazy values. So about the metrics, I think pulls and pushes per second is a really good metric to capture and monitor. It gives you a good idea of how the hosting operations within your system are changing and the type of usage you can expect in the future. System CPU is a pretty obvious one. I'd also keep a close eye on your JVM heap size, specifically the used heap size. You want to sort of see a nice sawtooth pattern of garbage collection working, but you don't want to see it too often, so you want to have a decent buffer between the amount of available and used memory. Take a look at your network traffic in and out. That gives you a good idea of your throughput of your system, and also database connection pool, because that also just tells you, is your database running slowly? Are you queuing database connections? And so on and so forth. Now, I think access logs are the most underutilized facility that Bitbucket Server provides to system administrators. It ships with the product, and unlike sampling, it captures every single event in the system. So it provides you with really, really high resolution of exactly what's happening within your system. There are tools to parse access logs and generate all sorts of graphs from them, available online and open source. And they really provide a wealth of information, such as splitting hosting requests with UI requests, how long these requests are taking to process within the system, which users are generating these requests. So if suddenly you have a bad actor that's really hitting your system hard, it's pretty easy to identify that with access logs. The other thing that I think is really, really important when thinking about access logs is often you'll see something like a load spike within your system, a spike in resource usage or whatever it may be. And when you're looking at your sample metrics, like say your CPU usage, you generally make one of two determinations. You know, has the CPU usage increased because I've suddenly started seeing a whole lot more load on my system? Or is it because something downstream is running more slowly? And without actually combining the access logs with the metrics, I can find it sometimes it can be quite difficult to figure out exactly what's going on. So make use of both of them. There are lots of really good tools for that. We make use of our access logs all the time within our production system. We have various dashboards set up to make use of these access logs. So we've discussed monitoring and access logs, and I think it's very important not to alert on every single thing you monitor. I think there's quite an important distinction there. I think you should try to at least collect as much as you can, set up a dashboard with what you think is the most important things, and then choose a few different metrics to alert on. Otherwise, you'll just be driving yourself crazy with false positives and managing these metrics. So the most important thing to alert on is disk space. Why? Because if you run out of disk space on your Bitbucket server volume, where you're hosting your repositories, that can actually lead to data corruption. And nobody wants to see that happen. So always make sure you've got a decent amount of disk space available to your system. Take a look at hosting tickets, particularly queued hosting tickets. We have alerts set up internally that if we're queuing hosting tickets for more than 5 minutes, we get an alert. Now, I think it's okay if that happens every now and then, but if this is something that's happening all the time, you probably want to look at upgrading your instance, whether it's a data center instance and you're adding new nodes to it, or you're upscaling your current instance, or you're looking at some other mechanism like maybe mirrors or something like that to get all the flexibility that gives you, which I'll discuss later. The other thing that's really important is to keep an eye on the event queue length. Bitbucket Server has this internal eventing system where we put all sort of system events on that event queue, and it's actually kind of important that those events get processed. If, for some reason, those events aren't getting processed, all sorts of bad things can happen within your repository. The SCM-CACHE won't get invalidated. Basically, just bad things will happen. What we found is that if you start doing heavyweight work on an event queue, whether it's talking to the database, reading or writing to disk, that can really, really back up the event queue, which means that your system will just not be operating in an optimal manner. And we do tend to see this quite a lot with custom plugins. So if you do have custom plugins installed, keep an eye on this, and if you suddenly see a spark, take a look at what plugins you've added or upgraded recently, and maybe roll back that change. We provide a status endpoint. It doesn't provide too much information, but the point here is that it's no good having all this monitoring, alerting, etc., if it doesn't actually catch that the website's entirely down. So have some mechanism for making sure that your system's actually running. What we do internally in terms of backups is that we have an alert sent out whenever a backup fails. So again, it's all well and good taking your backups, but if they don't actually pass, then if they're not actually happening and then you need them at some point, then like bad times happen. So set up an alert. If your backups fail, tell somebody somewhere. And finally, your database connection pool. If you're queuing database connections, that's a sign that maybe your database system is too small and it needs to be upgraded, or you've got some non-optimal queries running. So keep an eye on that. Okay. In terms of backups, I don't think I need to tell you all too much about backups. You're all professional system administrators. Bitbucket Server provides you with 3 different backup strategies. If you're running data center, you can do zero downtime backups. Otherwise, you can use our DIY backup clients, which makes use of the native tools available to your system. For example, MySQL dump, PG dump, etc. Or you can use the backup client. Now, I wouldn't really recommend the backup client at all because it's just really, really slow. So either use the DIY backups or zero downtime backup. Think about your backup aggregation and storage strategy. How long are you going to keep your backups for? And also, just be wary of the fat finger. So what we do on our production instances is we actually run in AWS, and every time we take a backup, we export it to another read-only account to prevent anybody from accidentally deleting those backups. And think about your recovery point objective and your recovery time objective when you're considering backups. In terms of capacity planning, how do you go about doing capacity planning? Well, once again, I think your access logs are a really, really good source of information. It allows you to break up hosting operations to UI operations, see how that trend is changing over time, see how different actors are changing over time. For example, your build instances, your automated bots. We've experienced some things within our own production instances where we have teams who suddenly start really hammering our REST APIs. And by using the access logs, that's a really good way to pull that out. Hosting tickets is another way of trying to get a good idea of what your capacity is looking like. If you suddenly start queuing hosting tickets, every now and then, once a month, and then once a week, and then it's happening daily, that's a good indication that it's time to upgrade. It's time to add more capacity to your system. And finally, heap size. If you find that you're constantly doing garbage collection, you probably need to think about upgrading. So the number one question I get asked about AWS is, can I use EFS? And the short answer is no. The reason for that is, as I mentioned earlier, because of the way Git does I/O with lots of random reads and writes, that means that EFS and the way EFS is designed, it just doesn't really scale for that. So whether it's whatever storage solution you're using, just make sure that when you do your benchmarks for that I/O, that you're testing that specific access pattern of lots of small reads and writes. Generally, we've had a really good experience with AWS. And like I said earlier, we actually run our production instances within AWS. We've had really good experiences with RDS and Elasticsearch. And the other thing to just be wary of in AWS is network throttling, because we found that after some time, depending on your instance size, your network bandwidth can start getting throttled. So just bear that in mind, do some tests, make sure whatever instance you choose can sustainably support the kind of bandwidth you're expecting. In terms of general hardware recommendations, lots of CPU and memory is important. If you are using Data Center, I'd recommend even speccing up your NFS server with a decent amount of memory so that it can make use of the page cache. The right kind of monitoring and alerting can help you increase uptime, respond to incidents, and plan for the future. So why do you want to use Data Center? Data Center makes it a hell of a lot easier to scale. By giving you operational flexibility, it allows you to do all sorts of interesting things. It allows you to be more resilient under high load, and it gives you a really flexible deployment model. Due to the fact that you can set up active-active clustering, that gives you more availability. Zero downtime backup means that you don't need to take your system down for backups. And because of the way throttling works, and each node within a data center cluster essentially gets its own set of hosting tickets, that means that you basically can support a higher capacity of hosting operations. Also gives you, because of that zero downtime backup, you have a lower RTO and RPO. If you over-provision your instance a little bit and you have a problem with one of your instances, or you want to, for example, provide security patches, it allows you to do things like rolling restarts. And the way zero downtime backup works is actually pretty interesting in that with Bitbucket Server, you essentially have two sources of truth. You have your database, which is your Git repository, and you have your file system, which is your Git repository and all that information on disk, and you have your database, which contains information about pull requests, comments, likes on comments, and so on. And with zero downtime backup, what we recommend is trying to take your database and file system backup as close to each other as possible. And then we have an integrity checker that runs on startup that will reconcile any differences between your database and your repositories on disk. Mirrors are awesome for distributed teams. I mean, I know personally, our main production instance is based in US West 2. I work in Sydney. Everything I do is done through mirrors. It makes whenever I need to clone a project, it just happens so much quicker when I'm using a mirror than if I'm going all the way to the other side of the world. And with push proxying, it means I don't need to do any sort of funny setup around setting remote URLs or anything like that. It just works. And the other awesome thing about mirrors is it really allows you to not only have geographically flexible deployment, but it gives you a really flexible operational model. So, for example, if you have a team that's really, really heavy CI users and keep hammering your primary cluster, what you can do is you can set up a mirror to just specifically serve that team, which acts as a bulkhead against bringing down the rest of your system or reducing the service for other users. And at Summit, we just announced, I've got it as instance consolidation on the screen, but it's actually called data center migration, which allows you to consolidate multiple instances into a single data center instance. So why would you want to monitor multiple data center instances when you can manage one? Git uses lots of CPU and RAM. I think that's one of the things that I found most surprising about Bitbucket Server and the way it has to work around that. Also does lots of small random reads and writes. Hosting tickets protect your system from overload, and the SCM-CACHE is a really, really awesome feature. Make sure you choose good tooling, because it can really, really help. Make sure your tooling supports high-resolution metrics for a long time. I'd say try and find a tool that supports full-resolution metrics for at least 6 months and supports different log axes and derived metrics, like I mentioned in my talk. Make use of the access logs. They're a really, really awesome facility. Pick a few key metrics to alert on and monitor the rest. You can't alert on everything. You'll just drive yourself absolutely crazy. So capture as much as you can. Set up some dashboards with some important things, but really try and focus your alerts on a few of those key metrics. And with Atlassian Data Center, I think it makes your life as a system administrator a whole lot easier by giving you flexibility in how you deploy your systems. It allows you to deploy across the world. It gives you all sorts of cool features for administering your system. Thank you.
Cool. Thank you, Rick. We have time for a few questions, if anyone has any right now.
Thanks. Very good talk. Very informative, practical.
Thank you.
I have a question regarding the load balancing strategy. So
Yeah.
you mentioned SCM throttling. However, the way the load balancer distributes the load is still based on sessions, which is a bit random and not somehow choosing the node that has the least load. Is there any plan, like guidance, on how to introduce this kind of strategy on the long term?
Yeah, so we currently recommend using session affinity for HTTP UI operations, but for Git hosting operations, you can pretty much choose whatever strategy you want. So you can just choose a pure round-robin strategy, you can choose least connections, or whatever strategy your load balancer supports. In terms of the UI operations, it is actually possible to configure your system to do round-robin using Hazelcast for sharing session data, but that's not something we've tested extensively internally, so your mileage may vary on that.
Thanks.
Hello.
Hi.
For the data center, the geolocation, is that mirroring, is that read-only, or can it also work for the just writing, reading, all the way?
It's only Git operations, so it doesn't support pull requests or any of the UI operations. It's just purely for Git.
Anybody else? Oh, around there?
Hi, also, thanks for the talk also. How do you monitor those hosting tickets or queue length? Because that's an internal value, as I expect.
We make all those values available through JMX. So we have a documentation that lists all those values and gives a brief description of what they mean.
Any other questions? Doesn't look like it. Great. Everyone, that's it. Lunch is now. Lots of great sessions and demos upstairs in the theater. Otherwise, we'll see you back here at 2 o'clock for the long-form breakout sessions. Thanks, Rick, and thank you, everyone.